Hi everyone. So welcome to Introduction to Python in the Lisbon Machine Learning Summer School. So the purpose of today's session is to introduce you to Python, assuming that you know some programming. So if this is your first introduction to programming, this will probably not appropriate to you. And in the context of the summer school, also note that if you're very familiar with Python, this is something that you can skip. And if you are familiar with Python but not familiar with NumPy, then you can also just skip ahead to part 3, as part 1 and 2 will introduce Python, the language itself. So my name's Louis. So normally I'm a junior principal investigator at Fudan University, and my main line of research is on the microbiome, the global microbiome. But I've been using Python for quite a long time now. And Python is now perhaps the most widely used language in the data science field. I mean, there's a lot of libraries and there's a whole ecosystem of packages that work very well all across data science, machine learning, and frankly all of the scientific computing disciplines. So I actually like to start off with some history. And so Python now is an old language in some sense. It dates back to the late 80s. And it's a successor to another language called ABC. And ABC was a teaching language. What this means is that it was designed to be very easy to teach. And the structure at the time was such that students come in to their first year of undergraduate, their first semester in computer science or some engineering discipline, and they learn ABC. And then later in their second semester, they learn a quote-unquote real programming language. And so hopefully they would have learned some basic concepts with ABC, but it was too limited of a language to be able to do real work. And so the students were then forced to learn a second language. And the research program behind Python was, can we have a language that's still very easy to teach, but is now general purpose and good enough that it can be used, not just throughout a student's studies, but even afterwards, in industry, in any type of application. And so in that sense, we can say that Python has been incredibly successful. I hope you'll see that it's still very easy to teach. But it has really been successful in terms of being widely used. I mean, there's different ways you measure this, and you have these rankings of which languages are most widely used on GitHub, or more people ask about on Stack Overflow or talk about on Twitter, blah blah blah. And obviously each of these rankings will be slightly different, but Python is always up there in the top 10. Originally, it had incredible success in the web development area, and now more recently, as I said, in the scientific programming field, and specifically in sort of data science, machine learning. Okay, so this is so a little bit what was the design intent of Python. So it's supposed to be both easy, but also general purpose. So what does Python look like? So let's start with the classic. Print hello world. So print, so here you can see it's a keyword because it's in green, and it's a special function. So functions we call with parentheses, so name of the function, parentheses, and then hello world. And what does this do? This prints hello world. So, and here I'll take the opportunity to say, so all of these slides, they're part of something called the Jupyter Notebook. And so if you're watching this on YouTube, you can find the link to the Jupyter Notebook below. It's a GitHub link, and you can download it and run it locally if you install all of the dependencies. And you'll also find a link to Binder, which is this tool that allows you to run all of this on the cloud without having to install anything locally. If you're watching this as part of the summer school, we'll probably also make it available on the Zoom chat, the links. So you can follow along. You can run everything I'm running. I'll be doing this well, not interactively, but I'll be running it live as well, and you can run it on your side. All right, so here I'm switched over the window, and so let me actually, just to be sure, I'm gonna clear everything and restart. Okay, just be sure. Okay, so here's my data, or here's my presentation, and so here's where we were, print hello world. Okay, so in this interface, we have these little things, these blocks. So the name they use is a cell. So this is a cell, and this is also a cell. So some cells are text, and some cells are code. So here, so this is a markdown cell. So you can use markdown code. So here's, I don't know. Sorry. So yes, so markdown code. So if you put this hash, it will be a heading, and some cells are code. So if they're code, then we can run them, and there's several different ways of running them. So you can click this little play symbol, and boom, hello world. You can also select the cell, go up here, and run cells. And as you can see, you can also run all of the cells, so which is not something we're going to do now. And the other, finally, and I'll be doing this a lot, if you just select the cell and if you press Control and Enter, it also runs the cell. Okay, so, and obviously if you edit and run it again, it prints. Okay, so these are the mechanics of Jupyter, and you can, I'll let you explore a bit on your own time. You can insert cells, etc., and run them. Okay, let's do a more complicated example. So here's an example. Give you a couple of seconds to look at it. Okay, so we'll go over these things in a bit more detail in a couple of minutes, but what I want you to get away from this example that you've never seen is this idea that Python is executable pseudocode. So people is often attributed to Bruce Eckel. I'm actually not 100% sure that he was indeed the first person to say it, but this concept that, if even someone who is not familiar with the language per se can look at a piece of code and guess correctly what this is doing, and you can see that this is computing the average of this list of numbers. So here we have two variables, total, that accumulates the total n that counts the numbers, and then we print the total divided by n, so we print the arithmetic mean. Okay, so let's actually now dive into the details. So first of all, this is a bit of a word of warning if you're using the notebook. So this is a little bit like when you're running on the command line or on the the REPL shell. So that if you set a variable here, you've set the name a to refer to 1, and then we can use it in a subsequent cell, and it refers to a. Perhaps not too surprising. And so here a. Also note that we can print things explicitly, but we can also just refer to them, and the last line of a cell will get printed. And a little bit more confusing. So here we can set a to 2, and we can go back up and now print a, and a is 2. So here you can see that the order in which the cells are displayed, it's not the order in which they were executed, and so maybe these numbers can help a little bit with debugging, but sometimes it does get really confusing, and then you can restart everything. So turn it off and restart. So restart and clear output. So let's do that. And now you can see, all right, so these numbers are gone, and if I print A, it will tell me that there's no A. All right, so here. Okay, so these were the mechanics of the notebook. So let's now switch to talking about the types that we have available in Python. So Python is a dynamically typed language, and the types are generally implicit. And we have the basic types that are built into the language. So we have numbers, we have strings, we have lists and tuples, and we have dictionaries and sets. And so let's go one by one over these. So I'm actually going to switch back. All right, okay. So numbers. So the first type of numbers we have are integer numbers. So these are whole numbers, and syntax shouldn't be too surprising. A equals 1. So as you've probably already guessed, like many languages, especially in the C family, Python uses equals to mean assignment. So this means the name A is assigned to the object 1. The name B is assigned to the object 2. The name C is assigned to the object 3. And these are integers, and then the rules of arithmetic apply. So this is B times C, and then the result plus A, right? So we also have floating point numbers. So floating point numbers are written like this: 1.2, so 2.4 and 3.6, and these work as you'd expect. So I'll note that, so in the basic Python, integers are infinite precision. I mean, infinite up until the limits of memory on your computer, and the floating point numbers are they have limited precision, so you can get these rounding artifacts. So so the computers don't exactly represent real numbers; they represent a rounded abbreviation, and so you can quickly get results that are approximately true, but where you have these rounding errors. Okay, so if you mix and match integers and floats, everything works, because implicitly the integers get converted to floats, and then computation proceeds. So let's just, all right, this was probably not too complicated, but let's just see it. Okay, oh yeah, 7. Okay, well, I'm gonna believe that math is correct. And here, so A is an integer, but the result is 13.0. So in this case, 13.0 is the floating point number 13.0, which is a different object from the integer 13. So we have all of the basic arithmetic operations, A plus B, A minus B, A times B, and then exponentiation. So A to the power of B is spelled A times B. And minus A is just the unary minus, so just flips the sign. Okay, now we come to the complicated one, which is division. So, right, let's start with a simple example. What's 9 divided by 3? 9 divided by 3 is 3. All right, good. All right. What about 10 divided by 3? So this is a slightly more complex example, because here we have actually two answers. So 1 is the kindergarten answer, where you have 10 cookies and 3 kids, and each kid gets 3 cookies, and there's 1 left over. So this would be the integer division. 10 divided by 3 is 3, with remainder 1. The other answer would be the floating point answer. So 10 divided by 3 is 3.33333, up to the limit of precision. We could also have an answer that's 3 and a third, somehow trying to represent the third, but that's actually doesn't exist in Python. But we do have these two variants. So the integer division and the floating point division. And so here, So the integer division, it's spelled this way, this a//b, so that's divide b, that's the integer division. So that 10 divided by 3 is 3. Well, the floating point division, so just here, just to make sure we got it correct, it's a divided, and I've converted to float explicitly, we have this and 333, and as you can see, there's a little rounding error at the end, but this is also a correct answer. So if you just use a divided by b, you get the floating point division. So here maybe I'll make a small remark. So the Python version that we now use is Python 3, and in fact, starting into 2020, Python 2 is not supported anymore. It's not being developed anymore, but you still might run into some Python 2 stuff, and this was actually one of the little things that changed in between the versions, so that this used to mean integer division and now means floating point division. Frankly, it's just for teaching, it's actually kind of nice that we don't need to keep remarking upon the differences between the two versions, because nowadays, we can say this is floating point division, period. Okay, so that was numbers. So let's skip ahead and talk about strings. So strings, so start with syntax. So first equals single quote John single quote. So name first is assigned to single quote something 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 single quote. So that's a string. We can use single quotes or double quotes. They're equivalent. The only difference is you can use single quotes, for example, as an apostrophe in the word don't within double quotes, and other than that, really, the language treats them as equivalent. We have the plus operator to do concatenation, and so this is the string first, then space, then last. So these are short strings, so they have to fit in a single line only, and you have this backslash character to denote to escape and to be able to input special characters. So for example, to have a new line, use /n for new line, there's /t for tab, and there's a few others, although /n and /t cover probably 99% of the use cases. So let's talk a little bit about string formatting. So string formatting in Python, there's now several ways of doing it. So the language as the language has grown, it's accumulated multiple ways of doing it. So this is the new style of formatting. So here, let's talk syntax as usual. Print. So this is a string dot format. So we're calling the format method on the string, and then we're giving it an argument, which happens to be another string. And so here's what's special is that within this string, we have these placeholders that are denoted by the curly braces. So in this case, have one placeholder, that's placeholder 0, and here we have two placeholders, 0 and 1. Actually, let me show you how this works. I'm going to skip to this one. And so when we format, what the format method does, it takes its argument and it inserts it where the placeholders are, so in order. So the first placeholder is placeholder 0, the second placeholder is placeholder 1, right? You can actually leave the numbers out in case that your placeholders are just sequential. So if you just have curly brace open, curly brace close, you'd have the first one will be placeholder 0, placeholder 1, as many as you wish, and that's it. All right, so this is the new style of formatting. There's actually something that's even newer that's called f-strings. And so as usual, let's start with syntax. So we have f, literally the letter f, and then a string, and so here's single quotes, and then we still use the curly braces, but now the curly braces can refer to something in the environment, to a variable in the environment. So here's an example. So username and refers to username. So here gets environment, and we can even have more complex expressions. So here curly brace A refers to A plus curly brace B refers to B equals curly brace A plus B. So it even evaluates that expression. So this is the new kid on the block of formatting. And there's also the old style of formatting. As I said, this has accumulated throughout the years. So I'm just going to show this one because you might run into it, and so you're not surprised if you see it. But really, there's good reasons why you shouldn't be using it. And so this old style of formatting uses this percentage sign, and so it uses it to generate placeholders. So here percentage sign S is a placeholder, and then it uses the percentage sign operator in the same way that we have the format now, so to replace into the placeholder. And so this, you might recognize this percentage sign S from languages such as C, where you have printf, the whole printf family that uses similar syntax, except that now here it's a little bit simpler, and there's good reasons why you shouldn't use this, so never use it. But if you see it, you can just know that this is kind of the old style of formatting. All right, so I mentioned that we were looking at short strings, so maybe you guessed that there was something that's long strings, and indeed there is. And so long strings are spelled like this, so triple quote, either triple single quote or triple double quote, and then you can have a piece of text that spans multiple lines up until the closing. So if you have initially three single quotes, you close with three single quotes, and if you have three double quotes, you close with three double quotes. Okay, and this prints the whole thing. It's actually from an old Kurt Weill song. All right, lists. Let's look at lists. So, all right. So syntax. Let's start with syntax. Values equals, or assign name values to, and then square brackets, something comma, something comma, something comma, square brackets. So we use these square brackets to denote lists. To access the elements of the list, we also use square brackets, square bracket index, and then the first element is element with index 0, and the second element is index 1. So you might have already guessed from the previous, from looking at the placeholder syntax, that Python is a 0-based indexing, so 0 is the first element, and so also here these are comments. So you can see, so the hash denotes a comment, and then whatever else follows up until the end of the line, this is a comment for human consumption, so it's ignored by the language. Maybe not so common. We can use negative indices to index from the end. So index -1 is the first element counting from the end. So that's another way of saying the last element. And we have a function called len, that gives us the length. So that's just the number of elements. So in this case, last element is 10, and it's a list with 4 elements. And okay, so we've actually seen implicitly this method calling syntax. We saw it when we were doing formatting, and here, so we have object dot method parenthesis, and then within the parentheses we can have arguments depending on whether it's appropriate. And so for example, there's a method called sort, which sorts, in this case alphabetically. And you can see there's a method called append, which adds something to the end of the list, and so now has changed the list so that it has an extra element. Okay, so one of the advantages of using the notebook is that we can get help. And actually, So if we add a question mark at the end of an object, and this object can mean, even a function, and then we execute it, we get a little help pop-up. So in this case, it's actually quite short, but it tells us, so what it does a stable sort in place. So in here, in place actually highlighted, it changes the list. So all right. And so also maybe if you haven't seen, so we can append, sorry, and you can see that maybe, so if I type S, another thing, I type tab, this case it does auto completion, and then sort, get this. All right, so this was a little bit of an aside. I'm actually going to comment this again. So in Python, lists can contain mixed types. So far fruits was a list of strings, but we can add a number, and we can even have more complicated objects with lists inside of lists, and this will all work. So in Python, a list is a list of objects, whatever those objects may be. So there's nothing. So we'll talk a little bit later that for numeric computation, often this is not appropriate, but in Python, an object is an object. All right, so I think this is the last thing before the break. Let's talk about dictionaries. So dictionaries. So syntax. So emails is assigned to curly brace, and then we have something, colon, something else, comma, something, colon, something else, comma. So this is assigning the key Lewis to this email, the key Rita to this email, or generally speaking, this string to that string, this string to that string. To access it, we use the same syntax as we had with lists, so curly brace and then the key. In this case, the key is more than just an integer. It can be a string. So this is the same structure that in other programming languages could be called a hash map, a hash table, just a map, an associative array. So this is the same concept where you're mapping from a key to a value. We have also, we can use the assignment syntax like this. And so here actually these two lines look similar, but these are different operations because we can add a new element, or if the element exists, it replaces the previous element. So, and actually both of these are valid emails for me. The other ones are made up. The function that we saw before, len, so the len function also works for dictionaries and returns the number of elements. Okay, and then finally, there's something called none, that's spelled capital N-O-N-E, and like this, there's that, and it does nothing. It's just very useful as a placeholder. So in some other languages, you have something called the nil or a null pointer, or the unit object or something like that. And so it's often going to be used to represent the absence of something, and so you have none. That's it. That's all it does. Nothing. All right, and so we'll be going into Python control structures, but here we have a little break, a little Q&A, and so I'll hope to see you back for part 2.